Hello, welcome back to the channel and welcome back to this series where we're exploring shapes. In last week's episode I used Pythagoras' theorem to find the lengths of a side of a right angled triangle if you know the length of the other two sides. So that gives you that famous equation a squared plus b squared equals c squared. However, what happens when you only know one side and an angle, or if you want to find the angles within inside of right angled triangles? For this you have to use something called trigonometry. So I've drawn out a right angled triangle here, and confusingly, and this happens at GCSE level and is one of the main causes of confusion when dealing with triangles, is what we call each side changes. So in Pythagoras' theorem we use the letters A, B and C to denote the sides, and C being the long side and A and B being interchangeable for the other two sides. And what makes confusion is we also have an A when we use trigonometry, but the other two sides also become O and H. So if let's first of all consider this right angle triangle. We have the right angle down in this corner and we have an angle which I've called theta in this corner. So we start off with the longer side first, which, as I say, from Pythagoras' theorem is normally the C. Here we've called it H, and that's because it's actually standing for the hypotenuse. The side opposite the known angle, so this side over here is opposite. This is known as O, or the opposite, and the other side, which is next to the two angles shown on the triangle, so next to the known angle and the right angled angle, or the 90-degree angle, is called the adjacent, and we call it A. So if we know any one of these sides and the angle, we can find either of the other two sides. Similarly, if we know what the length of any of two sides is, we can find this angle theta. And to do this we use sine, cosine and tan. So these are functions, and they're the trigonometric functions. There are a lot more trigonometric functions, but they are normally just variations on these three here. Let's start off with sine. So you have to use a calculator to be able to do this. It's not very easy to do these just by hand. So using a calculator, and I'll show you where these are on the calculator on the screen now. So if we type in sine of this angle has to be less than 90 by definition. We end up with a number which will vary between -1 and 1. And that number is equal to the opposite side divided by the hypotenuse side. So the length of the opposite divided by the length of the hypotenuse. So this is useful if we know the angle and either O and H, and we want to find the other either O or H. Because sine theta is this number, this then just becomes basic algebra. So whichever one is unknown, you have to rearrange this equation. So if you wanted to find H, for example, the H moves up to where the sine theta is on this side of the equation, and the sine theta goes down by where the H is. So H is equal to O divided by sine theta. If we wanted to find O, then we just take the H up to here, so it's H times sine theta. If we wanted to find the angle, what we have to do is, if you look on your calculator, above the sine key, you'll find a sine to the -1 key, and this is what's called an inverse function. And what this allows you to do is plug in the value of O divided by H, and then if you sine that answer, or sine inverse that answer, it will give you the angle theta. And then the rest, just the same rules then apply for these other two functions. So the cosine, people say don't call it cos. I really don't mind what you call it. Technically it's cosine, but if you're reading it straight off, it does say cos. So cos allows you to find either the angle, the adjacent or the hypotenuse, and again it has the inverse function. And tan theta is the opposite over the adjacent, so it allows you to find the angle if you know the opposite and the adjacent, or if you know the angle and either the opposite or the adjacent, it allows you to find the adjacent or the opposite. And again, you have the tan inverse as well. One thing to draw your attention to with the tan inverse is this tan theta. So if I draw it here, is the same as doing sine theta over cosine theta, because this would be equal to O over H divided by A over H, which is the same as doing, I'm just going to change pen to blue because this pen's running out, so this would be the same as doing O over H multiplied by H over A, which these two H's cancel out, so that's O over A there. So that's something just to bear in mind when doing these sort of questions, that all of these are still linked. Finally, there is a method that many people use for remembering which one of these has the over H, the A over H, or the O over the A, and that is known as Socatoa. So this would be the so, this would be the co, and this would be the toa. And all you have to remember to do is this becomes an equals after the S, after the C, after the T, and then there's a division between those as well. So this is the basics of trigonometry of a right angled triangle. In a future episode we'll look at using trigonometric functions if the triangle is not right angled. But now we have this, in next week's episode we will use these trigonometric functions, Pythagoras' theorem, to find the area of polygons, which we looked at a few weeks ago, and also something called composite shapes, when a shape is made up of or can be broken down into numerous other shapes. Anyway, thank you for watching. Please hit that subscribe button, and I'll see you again next week for some more explanation of maths.